In this video we're going to talk about the existence of neutrons, and this is our part 5 video inside of chemistry. And we're specifically going to talk about Rutherford and James Chadwick and how they contributed to the idea of the existence of neutrons. So let's get started with this video. So the first thing that we're going to talk about is Rutherford and what he and his colleague did. So Rutherford and his colleague, English physicist James Chadwick, so they both provided a clear experimental evidence for the existence of neutrons. And in our previous video, which was our part 4 video, we talked more about the experiment that they did, and the experiment was the Rutherford gold foil experiment. So if you're interested, you can go and watch that video out as well. So furthermore, in between the Rutherford and his colleague, he also mentioned that neutrons have no electric charge. However, this is as far as he got into the study of neutrons because they were really difficult to study until the 1932s. So Rutherford and his colleague didn't get far into the study of neutrons. They only found out between that there was neutrons because of the gold foil experiment, but however they couldn't get further than that. They also did mention that neutrons have no electric charge, but since there wasn't really advanced technology to study about neutrons, they couldn't get further into the study of neutrons. So this is when a new Danish physicist named Niels Bohr in 1913 came in and started to expand on the idea of neutrons. So the theory was an extension of Rutherford's model, which described the atom as having a dense, positively charged nucleus surrounded by electrons. So Niels Bohr, he basically contributed to Rutherford's model, and what he said was that in the middle, the nucleus or the atom in the middle had a dense, positively charged nucleus, and then all the electrons were surrounding around the nucleus. So furthermore, on the right, we can also see a picture of Niels Bohr's model, and Niels Bohr also suggested about energy levels. So Bohr suggested that electrons occupy specific energy shells or energy levels around the nucleus. So here we can see this is his model. In the middle there's the nucleus that contains of the protons, as he said, and then there's energy levels of the electrons flying around. So this was another thing that Niels Bohr suggested. And furthermore, he also talked about the stability of orbits. So Bohr's model explained why atoms are stable, and according to classical physics, electrons orbiting a nucleus should lose energy and spiral into the nucleus, leading to the collapse of the atom. Since the electrons are flying around, then that means that they would end up losing their energy and then the nucleus would grab them in. But then Niels Bohr said that there was also stability of the orbits, meaning that the atoms are stable and those electrons always fly around. So this was another contribution that Niels Bohr did. And now we're going to talk about a working model of the actual atom. So here we have a table that contains of the different parts of an atom, which is the proton, neutron, and electron. So the proton and the charge of the proton is obviously +1. So the plus is the proton. The neutron has no charge at all, so it's just 0. And then electron is negative, so it's just 1 minus, or you can just say minus. And then the symbol for them, for proton is P+. And then for neutron, it's n to the power 0. For electron, it's e to the power of -1. And the mass in grams, we can see here that the proton and neutron have the exact same mass. That's why they are inside of the nucleus. Both of them are together. And then for the electron, we can see that it is way lighter. So that's why, since it's lighter, that's why the electrons are always flying around the nucleus, which contains the proton and the neutron. And here we can also see that the radius of the proton and the neutron are the same, and then the electron has a way smaller radius compared to them both. So furthermore, the nucleus is the central core of the atom, which is composed of the protons and neutrons, which are collectively referred to the nucleons. And we found this out because they have the same mass and the same radius. That's why they are both combined together in the center. And then for the electrons, these particles occupy the space surrounding the nucleus. So since the electrons are smaller, they actually orbit the nucleus, as we said before. And once again, here is the exact same model that Bohr made, which is pretty accurate to this day. And furthermore, now we're going to talk about nuclear notation. So for the nuclear notation, we're going to take a specific example of carbon, so the carbon atom. If we start out in the right here, we can see this is the actual carbon atom. So there's the atomic number of carbon is 6, so that means that the protons and also the electrons are 6. So there is 6 electrons and there's 6 protons. So that means the mass of this is 12. So now if we look at the left here, these are the different types of isotopes that carbon has. And we're specifically going to talk about carbon -14 in this case, so this one over here. So here you can see that C is the chemical symbol for carbon. As we can see, C is there. And then 6 is the atomic number. so we can see that there's 6, and there's also a 6 over here, and this just means the number of protons and also the number of electrons. And then 14 is the mass number, so down here this is 14, which is the mass number. The mass number, you can get it by summing up the number of protons and also the number of neutrons. So if you add those together, you're going to get the mass number. So in this case, the number of protons is 6 and the number of neutrons is 8. That's why we get a mass of 14. If we just look at the normal carbon atom, 6 neutrons and there's also 6 protons, that means the mass of this carbon atom is 12. And then also for the carbon minus 14, this tells us that it's an isotope of carbon because it has 6 protons, 6 electrons, and 8 neutrons. So this is the nuclear notation of a carbon atom. And now we're going to go over a conclusion for this video. So this video provides an introduction to a working model of an atom. And in our next video, we're going to dive deep further into the development of a compound. So that summarizes everything for this video, so thank you so much for watching from Try to Be Useful, and we'll see you guys in our next chemistry video.